Hey Houston, we have no problems. We are going to be learning about something called chemical reactions today. Mr. Dmitrievich, what the heck is a chemical reaction?
Well, chemical reactions kind of sounds scary. If we view them as like recipes, it essentially allows us to go from reactants, which is what we start with, to products, what we end up with.
All right, so let's diagram like what the way chemical reactions work. You said something about you start with something called reactants, and it turns into, notice I'm drawing an arrow, folks, to products. Now, what does that mean, reactants and products?
Well, reactants are any things that you put together. And as we understand in a recipe, if you put a bunch of ingredients together, you're going to end up with something that most likely is a little different than what your ingredients were to begin with by themselves.
So flour plus sugar plus vanilla plus butter plus chocolate chips makes chocolate chip
I like
cookies.
where you're going with this one.
Right, so that's the reactants. But notice there's also this little arrow. What's the point of the arrow?
Well, we use that expression, we say yields or forms.
So it takes the form like this. For example, we could say A plus B turns into C, something like that, right? And then the turns into or yields is the arrow. Now there's some other things that we should talk about. Sometimes we'll put a little triangle above or below the arrow. What does the triangle mean?
That means we're changing the temperature, we're adding heat.
So if you see a triangle and it says it's heated, then you put a triangle. And then there's something else that goes into these equations, is it's these little parentheses. I got a parentheses S, L, G, and a Q. What do each of those represent, Mr. Dmitrievich?
Well, those tell us the state of matter, and the first three are pretty straightforward: solid, liquid, and gas. We're familiar with those states of matter. The last one is actually really, really important. It means that something is dissolved in water. And reality is a lot of our reactions, the way we get particles to meet each other, to react with each other, is we throw them into water, they dissolve, they float around, and they interact with each other.
So aqueous mean, and the aqueous, the word is aqueous, like we're aquatic, water, right? So it means dissolved in water. All right, folks, now we want to get to the hard part of this, and that is where we actually write out the chemical equations from the word. So let's do the one that you were talking about a little bit earlier, Mr. Dmitrievich. What would that be?
Well, let's start with something that we recognize as all the time, and it's hydrogen plus oxygen yields water.
Now, that's written out in words there, but what we need to do, of course, is to write it out in symbols. So what's the symbol for hydrogen? Think about that, everybody. Get at your periodic table. You say, well, it's H. So this is going to be H, right?
Ah.
What?
Yeah, you forgot the fact that it's Brinkelhoff.
Hoff!
There's certain elements.
It's the H in the Hoff. I don't write
itself.
H. It's H2.
Always
And
write
then I say
H2 when it's by itself.
Plus, now plus means I'm adding it too, so simple, right? Plus oxygen, oh wait, oxygen's the O in Brinkelhoff, so I don't write O, I write O2, and then we write arrow, and then we write the symbol for water. Now you know water probably is H2O. Now this might bother some of you right now.
Yeah.
You might say that, wait a second, there's one over here and two O's over here, and that's true. Later on in the next video, we're gonna learn about how to deal with that. But the key, folks, is that you write the correct formulas down to make it work. All right? So let me do another one here. Let's take, we have iron 3 oxide breaks down into its elements. So iron 3 oxide breaks down into its elements. What do I do with that one? So I've got to first of all do what? I have to write the formula of iron 3 oxide. Remember, that's the naming. We've learned about this. So iron, symbol of iron is Fe. The Roman numeral is the charge, plus 3. Oxide is O. Now get out my yellow table guy. I find he's in column 16, 2 over from the end. His charge is minus 2. And we'll play the whole charge thing, all right? So we say Fe2O3. Now notice how I did that, right? If you don't know how to do this, refer to earlier videos. And it breaks down. Now, am I adding anything to the iron oxide? No, so it's going to be just a simple arrow. So he's going to yield, he's going to produce his elements. So what are the elements, the symbols for their elements? Iron is?
Well, iron, as we just said, is Fe.
Just Fe by itself. Plus oxygen. Now, oxygen's tricky. What's oxygen going to be? It's not O, it's
O2.
O2. And again, this might bother you that we've got two irons, and we're going to learn what to deal with that in the next video. So on this one, folks, potassium plus sodium carbonate yields sodium plus potassium carbonate. So what are we going to do? Potassium. Mr. Dmitrovich, help me out.
So in this reaction, we have potassium, and that's just an element by itself. So you have to write that it's just an element. And so we just write K. No, be careful here, because we think potassium, we've learned potassium is K+, but potassium is only K+ in a compound. If you see potassium or any of these elements by themselves, it's just K.
Yep. And then sodium carbonate, that's one of those Roman things, right? Sodium and carbonate. So sodium is Na, charge is +1. Carbonate from your polyatomic ion list right here, right, is CO3, -2. So when I put those bad boys together, I'm going fast enough, but you should remember how to do these. It'll be Na2CO3. Make sense? But it yields, what does it turn into? It yields sodium. Again, sodium will be Na by itself. Remember, it's not the ion, like Mr. Dimitri just said, plus what? Potassium carbonate. So when we have how do we do that, Mr. Dimitrievich?
Well, again, now potassium is an ion because it's part of a compound. So that's K+, and carbonate, as we know from just before, is CO3 2-. And if you remember everything we've done before, we're just going to balance off the charges and end up with K2CO3.
So that's the answer right here. Let me say one other thing here, is that we can also, in general, figure out what our states of matter is. And if you look at the periodic tables, that almost metals are going to be solid, so we can actually say K solid. Na2CO3 likely is, when you have an ionic compound, they're almost always going to be aqueous, and this will be solid again also, and this will also be aqueous. You can actually determine the state of matter from that. We're going to talk some more about that in class, though. So in our last example, folks, we want to do this one. Barium chloride plus aluminum phosphate yields barium phosphate plus aluminum chloride. Now, this is a longer one, but again, same kind of an idea. And actually, let me show you what I think is a shortcut that's going to make life a lot easier for you. I like to create what I like to call a scratch pad. And I'm going to make this like a little bracket over here, and you're going to see why this works. We have barium and chloride. So I'm going to write symbol for barium, Ba, and I need to find the charge of the barium. All right, now we find barium in column number 2. So his charge is +2. And then we're going to write chloride, and that's going to be Cl, last column, -1. All right, put brackets around this. The second thing we're going to do is aluminum phosphate. You're going to see how this all works. You're going to do aluminum, and the charge of aluminum. Now, it's a little bit tricky. He's in column 13, right? So his charge, Mr. Dimitrich, is?
It's a 3+. You skip the middle block when you're counting charges.
And then we've got phosphate. Now, phosphate is a polyion, and his charge is PO4. His formula is PO4 -3. What I'm doing is I'm actually identifying all of the different ions. I have 4 different ions, and if you look carefully on the product side, they kind of change their connection, okay? So now I have to draw the right structures, or to indicate. So I'm putting barium with chloride. If I got +2 and -1, I'm going to again do this fast. You should remember how to do this. That's BaCl2. I'm writing barium chloride right here, right? And because it's +1 and -2. Then I'm going to put the aluminum with the phosphate. That's +3, -3. So they cancel out already out. So that's going to be AlPO4. Arrow. That's aluminum phosphate. Now I want to do the yields barium phosphate. So now I'm going to put the barium with the phosphate, kind of crossy-hatchy here, right? So barium and phosphate's a little trickier, but again, remember how to do this. You have to add up the charges to 0. So that's going to be, now watch me here, Ba3PO42, because I need to get to the lowest common denominator, if you will, is 6. So I need 3 bariums to get to +6, 2 phosphates to get to -6, plus aluminum chloride, and again, now I'm going to put these together, aluminum and chloride, +3, -1. You need to get to a 3 charge, positive and -3. That's AlCl3. And that's how you write what we call the skeleton equation. You have to write the formulas correctly, otherwise it will mess you up when we do the next step. Now it might bother you that I've got 1 barium here and 3 bariums here. We will fix that in the next video.